Okay, so we're on heats of formation. The first question says, determine the enthalpy change for each of the following reactions. So we look in the table 4.5.1, and we're going to take the heats of formation of the products. You're going to add them together, and then you're going to subtract the sum of the heats of formation of the reactants. So if you look here, C2H6 in the table is negative 84.7. CH4 is negative 74.9. So that's the sum of the heats of formation of the products. If we had coefficients other than 1, then we would multiply these individually by the coefficient. Okay? You're going to subtract C3H8, which has a value of negative 105.0, and then H2 gas is in its pure elemental standard state. So that means that it has a value of 0 for its heat of formation, which you wouldn't see in the table. Okay? Add that stuff together, you're going to get negative 54.6 kilojoules per mole of reaction. Okay? Trust me. Okay. Now, if you think it looks funny, it's this will be negative, but this you're adding. Okay? Okay. For B, you've got 2 SO2. So 2 times negative 296.8, that's for your SO2. And then you're going to add that to 2 water. Be careful on the states of matter when you're looking these up in the table, okay? So this is 2 times negative 285.8. So this is the sum of your products, okay? And then you're going to subtract, you have 2 H2S. So 2 times negative 20.2 for H2S. Add that to 3 O2. And this is 3 times 0 because that's oxygen in its elemental state, its standard state. And then that's going to go ahead and give you negative 1124.8 kilojoules per mole of reaction. Okay? Now, number 2 is slightly different. They're asking you to solve for one of the heats of formation, and you just put a variable of x in place of it. Okay, so they've given you the overall heat of formation, so that means your negative 878.2 equals 2 times ZNO, so 2 times negative 348.0, and then you're going to add that to 2 times negative 296.8 for SO2. So this would be the sum of your product, and then minus 2 times ZNS, which is what they want you to solve for. So I'm going to put X in place of ZNS. And then this is pure, so that's just 0, right? So I'm just going to omit it from my equation for simplicity purposes. You're going to end up solving for X. X is negative 205.7 kilojoules per mole after you do all the math.